Hello, this is part two in Agentic Coding. Did a video maybe about a month ago on how to be effective with using agents to write code. So now I'm going to go a little deeper into it because there's been a lot of interest and questions and so forth. So there are three kinds of ways of using AI. I'm going to recap this again. I put it into a table. So you've got AI assisted. This would be someone using Copilot, or maybe they're using Cursor or some browser window. They are using AI to help them write code. This could be writing specific functions, could be fixing a specific bug. You're like, hey, I've got a bug, here's the error, fix it. These are like you can call them like one-shot prompt assistants. I think of it like using the AI to help you pass a screwdriver. It's like the robot next to you that's helping you out. You can do larger work with this, but you need to really know how to direct it, how to control it, and so forth. There's a lot of this particular way of working with AI has been already used in a lot of enterprise environments and has an average of about 25 to 30-ish percent performance gains. So we're not talking about that today though. I just want to make clear what that is. The next is vibe coding. This often has no or very little setup. But the more the better actually for your success, typically more for prototyping or internal tools. Maybe your executive in your company wants a tool to do budgeting, financing, overview, and you want to connect all these things. You can really replace SaaS applications with your own application. Probably not rolling this out to thousands of customers usually, because the vibe coding has a lot of issues as you get further and further into trying to iterate it, but it can be really good for getting an idea out quickly as well. The last column, which is what we're talking about today, is agentic coding. So this is the AI is writing software, but it's doing it with a network of agents. It's not just a single AI. And so you're engaging a process, and that process is what ensures the quality and also helps you to be able to write much larger volumes of code or to do complicated code refactoring, which is traditionally really hard to do with just AI assistants and often leads to frustration or just, toss it out the window type situations and go back and just write it by hand. It's a lot more setup, which is what we're going to go into. So it's not well suited to one-off coding activities. Your client calls you up and says, hey, can you add, I don't know, another menu item on my dashboard? Like, go in and do it, or write it with an AI assistant. Don't approach it with this agentic coding. This is more you're building out a whole new epic feature in your software, or you want to write all of the software using AI, or you want to do a major refactor and you're interested in tapping into agentic coding. This is very new. We've been doing it now for about 2 months, which is not that long. We went through a lot of pain and suffering to get to where we're at in terms of knowing how to use it effectively. There are others out there also knowing how to use it effectively. We're not the only ones. We're probably not the first ones who are figuring it out. But yeah, it does have huge potential, and honestly, it's the future of where coding is going, where your programmers are overseeing a whole bunch of agents. And one thing I've been experimenting with is actually running multiples of these agentic coding frameworks in parallel. And every single time one of them waits for me to review, the other one is going. So you can achieve crazy productivity speeds when this approach is effective. You just need smart people at the head to orchestrate it. You become an orchestrator. Okay, so I already kind of talked about this, the perception difference. AI assistance is you're using the AI to help you speed up. Agentic development, it's more like a car factory where all the robots are building the car and you're up in the little control tower, monitoring, optimizing, figuring out how to code the brains of these little agents, solving problems when they don't work well together, and so forth. You still need software engineering, but it's a different kind of approach. It really is. So right now at this time of writing, we're in February beginning. I would say personally, I still find Claude Code to be the leader. Google's anti-gravity is catching up. Cursor just released in January 2 features that were missing to kind of make it compete with Claude Code. So I think there could be potential for Cursor to start heading the race as well. Nice benefit of Cursor, if it can catch up, is that it's model agnostic. Claude requires you to use Anthropic. Google requires you to use its Gemini agent. When using Cursor, use whatever you want. You can even plug in your own AI models through API calls that can be very low cost models, right? Devon and Windsurf, I honestly don't know that well, but I've been looking a little bit into them as alternatives. My impression, though, is from what I know, is that Cloud Code is really still the leader in this. Devon is a lot more hands off than Cloud Code, for example. Okay, so the first thing you're going to need to do, so I'm going to go more practical in this video, is you're going to want to identify what agents you're going to be needing for your software development, and you're going to want to create them. There's documentation I can point you guys to if you want to have some examples of that. I put a little code snippet here in top right of the screen of what the start of that might look like. And below here's kind of the overview of what I would say are the minimum agents that I think you need to be successful based on our experience, my experience. You need a task manager. This agent's job is not to write code. It's to structure a job, a series of tasks, and then to make sure that the other agents are doing their work, verifying that they're doing their work correctly, escalating when there are issues, and you provide rules for this agent to understand when that's true. And then you've got what is the task manager managing? It's kind of like a project manager. I would say a good ecosystem start is a developer, a tester, and a software architect. All three of these have different objectives, different lanes. I would say you want in general to have as few agents as possible. You don't want to have 20 of these. You really want to have the agents that you're actually using, but you do want to make sure each agent has a very clear focus and that their objectives are very clear. And I would say also antagonizing is very helpful. So what I mean by that is if you have a developer, the developer gets brownie points, like it gets success, it gets pat on the back if it's writing code and the task manager says that it has completed the code assignment. The tester gets bonuses for finding problems. So it actually is antagonistic to the developer because the tester is going to get a pat on the back when they're able to find more bugs or more problems. And this is healthy because you want the tester to struggle to find problems and to say, I can't find anything wrong. It feels deflated, but your task manager and you are feeling inflated, right? Like that's actually what you want in this case. But the tester, you still want to complement it in essence through your prompting that it's, what its job is to find those bugs. The software architect, I think this is also crucial, especially when you're doing refactoring projects. I would say if you're not doing refactoring with this, it's maybe not as critical, but what the software architect does in principle is making sure that you have well-structured code, your developer isn't creating duplicate functions that are similar but different. It's kind of like the code police about adhering to certain standards that you establish that you want your code to have. And it can make sure upfront at the beginning of each task that the software architect lays down additional insights and guidelines for the developer. And then when the developer's done, it also has another step that the task manager plans in to review the code that's written. And the software architect, they're getting brownie points for finding problems in the software architecture itself, the design patterns that are, and so forth that, maybe the agent didn't follow. Okay, so this slide talks about the different agents. You can pause this if you want to read this. And then the one little tip there that I made. So it's an example. It's a good example. So even though I have here these 4 agents for one of the applications that I'm building right now, the tester needs to actually do a batch execution of the software, and then that software then writes to log data, and then that data is what the tester checks. So it can all run without a human needing to run the software, it just runs itself. But that actual batch execution of the tool could end up being its own skill or its own sub-agent that is delegated to. So you might have some highly narrow, you could have like a web research agent that is called by one of these other agents as well, for example. So once you've got your agents, you want to start building things around the ecosystem. I think the most important thing to focus on next is your commands. So the commands are important for a few different reasons. What they are essentially is they save you from having to type out a whole bunch of instructions over and over every single time you want your Claude code or cursor environment, whatever, to continue or to build these documents. It includes all of those instructions. You just do slash dev docs to build a new uh, project documents, or you do continue if you came back tomorrow morning and you just wanted to keep going where it's going. The commands are also important because they help the AI that you're talking to, who's like your main interface, to realize that they need to engage a network of agents to perform the activity and that they shouldn't be doing the job themselves. Because I mean, I could give a whole video on tips and tricks, but one thing that can happen if you're not using commands is the AI you're talking to might start to do the work of the agents rather than delegating to the agents. Commands really tighten that up and make it pretty pretty fail proof. I haven't seen issues once you're using commands. You can also add hooks and skills. I'm not going to go into hooks and skills today. This video is going to be already pretty long, but I would look into those as well to support your ecosystem. So how how do you approach a project once you have got your agents and you want to go from idea, we need to refactor the code, into specifics? Documentation, documentation, even more documentation. It's kind of insane how much documentation you need in order to get a 0% or near 0% error rate, which is our goal, because you want the agents to be able to code everything and to never have problems, never, in quotes. I'm sure they will, but in general, you want it to be able to go as smooth as possible. And so how you solve that is right now today is by having really extensive, well-written documentation. There are different documentations, approaches, technical specifications. Um, I recently was recommended to try using an ADR, architecture design requirements document format. I must say that that was a great tip because we've gotten the best results now with using an ADR. So first thing you do, write your ADR for whatever it is, your new feature in your software, your monolith software, your giant application, or your refactor goals and objectives, whatever it might be you want to be doing. Then get each part of your ADR to be broken down into its own sub-document. So I list them here as step 1, 2, and so forth. And then another layer of documentation is created because from each step, then we're going to be creating the actual plan, tasks, and context, and maybe some other documents as well. So it's kind of a pyramid of documentation that's being created. So how do you make an ADR? Maybe you know how to write it. You want to write it yourself? Go for it. Or maybe you write it and you have the AI help you. You can also have the AI just write it for you all its own and have it ask you questions. But if you're doing this, you really need to know how to drive the AI. You need to understand what you're building, because we don't want to end up in vibe coding, right? So I would say make sure you have your software architect, your tech lead, or just a really knowledgeable product owner manager who's helping to write this, a technical product manager, I would say. And then other tip here I would say is that the model that you use to create the ADR is not necessarily always the same model as going to be writing the code. And it's worth trying out different models. I've seen, for example, some of these examples you hear is on hydraulic simulations software code that I've been writing, or the agents have been writing. And that has had the most success with the scientific models using Gemini, not Opus. And then a separate project, this was more of a client inquiry, and it was related to taxation laws. And again, Gemini had far more accurate information than Opus. So, don't get just pigeonholed into your model of choice and think it's better all the time. You really want to try out different models, especially upfront when you're doing this documentation, and then when you're doing task execution with code. You want to do out smaller tasks, see the quality, compare, benchmark different models, make a decision based on a sizable sample set, and then you can scale it. Once you have the ADR, so here I'm just showing, like, breaking it down into steps. I'm trying to show an example here. It's hard to show the entire process in a slide deck and without spending an hour or 2 hours of just doing screen shares. So bear with me if some of these things feel a little discontinuous, but hopefully these examples are still helpful. So main tip I would say when you're breaking down the ADR into steps that I found is very helpful is make sure you're telling your AI, if you're getting the AI to break down the ADR into steps, that we're writing this ADR breakdown for a junior developer. It's funny because we think of AI as being super intelligent, super powerful, but if you write down specifications and documentation so that even a junior coder could write it, you're going to get such nice tight guardrails that when your developer is writing code, they're not going to have your AI developer is not even going to have any questions. They're going to be like, I know exactly what to do. And they're just going to write all the code. And then your catch systems with your agent that's doing testing and your other agent that's doing the software architecture review, both before and at the end of that process, is really going to tighten up that loop. And you're going to have you're going to have such less few problems by doing it to this level of degree. So don't give the AI any space for interpretation. All that interpretation is done up front in the documentation, which is the thing that you're reviewing. And this is not because you're going to find no problems after, but you're going to find way less problems after. Maybe, our goal is to find less problems at the end than you would if a person was doing it, right? That's because otherwise, why are we doing it this way? So other things to think about when you're creating the breakdown into steps is your acceptance criteria. And that is both from the agent perspective and from a human perspective. Are we at a point in this step where a person is needed or should be leveraged in order to test something? Maybe you need to have a visual check on things. Maybe the refactor has hit a certain point where the test agent is going to prove something is working, and then you, the person, want to also double check it to make sure you agree. Certain acceptance criteria could be, we've refactored into this other design pattern. So you, the person at that point, would be mainly just checking that that design pattern has indeed been completely refactored. I've had also situations where I've used AI agents that are not part of the project, so totally external, reviewing the results and giving their independent opinion. Typically, I'm using a totally different model provider. So if I was using Anthropic to write the code, I might use Gemini to review it independently. So things to think about there in terms of your acceptance criteria steps. The acceptance criteria is also important because you want the agents to be reviewing the work that the developer is doing. So what is it the tester needs to review? What is it the software architect needs to review? Or some other agent you might have in there. Maybe you have a client UAT agent who's doing the testing themselves, and they have their own goal, which is to, they have their own expectations or their own feature sets that they're expecting, and they want to see it being proven. Now that agent is part of your acceptance criteria loop. I would say also not a bad idea to have the AI think through what are the risks, what are the edge cases, what are the potential pitfalls that the junior developer might have up front, and to document them. It's super helpful to, again, you kind of proactively prevent edge case bugs as you're writing the documentation. So recommend it as well. Okay, so once you're creating the build docs, dev docs, it's basically your epic story breakdown. These top three I find are the most essential three documents. So it's the plan, what are we building and why? The context. Context is an interesting document. This is where you're basically tracking the memory of your collective, because every single agent goes into the context and adds its little bit at the end of its own analysis. And then when a new agent picks up where the other agent left off, they can read the whole context document plus the extra bit at the end that the last agent added on. And so you're creating a collective kind of shared memory pool. It's also important if you shut down Claude Code and tomorrow you go back to this project, your system can just pick up where it left off, even with a new prompt window, and there's no context lost. So really important. And you can get a lot of issues if the AI is talking to you in the terminal or in the chat window when it's not writing to this file. Another tip I found, when you, the person, are part of the development process, because that also sometimes is the case, that you, the person, needs to provide your own feedback, or maybe you're seeing an issue and you want to give some feedback. If you use the context file as well and just put at the end, this is my input, or these are the things I think I'm seeing now that we should be testing that we're not yet, or whatever it might be, adding it into the context is really helpful, because then the agentic network still keeps working within the same process. You're not breaking process. You're not the CEO who goes in and tries to suddenly micromanage and do the work for the team. You just become a part of the team of agents, and you are giving input into that system. You have to know Though when you do that, if your build dev documents have a certain task step and you're throwing in something into the middle, you could really confuse the task manager. So there is a right and a wrong way to do that as well. Okay, back on track to the slide where we're trying to get to. So that third document is the tasks. That's really, I'm going to show an example of that. That's really just your checklist that the task manager is creating. That is, we're going to do step one. If the whole document is step one, then that might be like 1.1, 1.2, 1.3. These are all the sub steps and the things that need to be done and by who. I think you'll see in the example that one step actually has multiple phases and each phase has multiple tasks. So essentially the task document could end up being big. It could be like 800, 1,000 lines of tasks that need to be done for that step. And then some other documents that I wouldn't say these are essential. These depend on what's going on, but a code review from the software architect could be an important part of the documentation, and you might not want to have that in the context, so you can reference it because it might become part of the assets that is then referenced by the tasks and created, let's say in task 0 or task 1. Then if you could also have a validation report, there's a typo there. Validation report for the tester could then provide that report and analysis of your log files, again, referenced. And then same thing if you had like a scientific audit or any other kinds of audits that need to be done. So all of this is really being done by the task manager. The task manager is your project manager agent, and it's defining what we're doing, who's doing it, which agent's going to do what job for those tasks. We're going to determine also how we're validating it and how we're maintaining. Apparently I have problems typing validating. I mistyped it on the right as well. All right, so here is an example of some documents that were created. This is step 1.3, because this is a big enough project that each sub-step is being created into their own document. So it's actually a pyramid that is 4 levels deep of documentation. Here we have, this is for hydraulic simulations. So we have the date, reference documentation that it's being pulled from. Step 1, restructure. This is a refactoring initiative. And you can see here that the scientific and software architect need to create their documentation as part of phase 0 before we execute. Then we can look here in the tasks. Here, the tasks this is a success, right? This whole mini initiative was run through and was completed with no issues. So here we have, for example, in phase 3 testing, we have some tests being run in batch mode, validations, looking for certain markers in the log, looking for the values to be at or beneath certain values, whatever the test criteria is. And then, here later on in that file, the same task file, we have the architect reviews the code changes, confirms that everything was correctly applied, and any notes that it has. And then if both of the scientific and software architect agents are approving, and then what our acceptance criteria is, and then you can see little X's were put into these checkboxes because they were completed. So, all right, let's think about this a little bit bigger now. So, in practice, it takes time to set this up. I would say it's important to be patient. Building your first project with an agentic network is a lot of overhead, and you're making an investment. I would say, though, that the lessons you learn from building your first or second project with this network are definitely reusable knowledge and expertise, which you can reapply and keep refining over time and have a benefit for all future projects. We're set up now that if another big project or refactor comes our way, we don't need to rethink. We've got agents that we really like. We know which ones are working. You get a sense of where the pitfalls and the problems and the typical places that they trip are, so you can kind of preempt them and think ahead because you know where the limits are of these agents. And those are all things you learn as you keep using this system. But yeah, don't get sucked into using this for a big project. And sometimes on a big project, we're still running AI assistants in addition to this agentic network. And we actually run 2 different interfaces into the same code base. So we run Claude Code for running the agentic build outs and the documentation, the task flow, and it's highly structured. And we never write into Claude Code prompts that we want the AI to respond to. It's all just driving the agentic network. And if we want to talk to the same code base and use the AI to more assist a coder to do one-off little things, we use Cursor with its own uh, model network in there to do those very specific collaborative AI assisted work on the same code base. So just wanted to point that out because you can actually combine AI assistants and agentic network together. And I would say split them apart so you don't get context corruption, context rot by trying to use the same user interface for both. Largest gains from big projects, right? That's where this shines. So last slide, how do you get started? Claude Code, I mean, pretty easy to find. You can just Google it. And then these resources here, the builder methods I have looked into a little bit. I got a tip about this Diet 103 Claude Code Infrastructure Showcase. It's a Git repository. You can clone it and start from it. It gives you some starting points for agents. I think we ended up changing quite a bit of the agents and we added a continue command that wasn't in there, which I ended up finding was extremely useful personally, right, for what we're doing. But it is a good starting point if you want to see, what are some agents might look like and, build from there. And then Human in the Loop I have not used yet, but it also came recently recommended to me as another kind of overlay that you can consider for agentic coding. All right, that's it. If you're watching this video and you want to get personalized help or you have questions or something like that, happy to meet with you, talk 30 minutes about whatever your coding software problems needs are, answer some questions, give you some tips. And if you did want to bring me in for workshops or trainings or assistance or anything like that, more hands-on and specific, this is something I'm quite passionate about and I would love to help you out. So let me know if you're interested. All right, take care. Thank you for watching.